Good afternoon, everyone, and welcome to MOS Live. Today we're talking with Museum of Science educators all about space. My name is Emily, my pronouns are she, her, and I'll be keeping an eye on all of your questions today. Thank you for those of you who are tuning in on Facebook or YouTube, but please note that we are not able to share your comments with our educators from those platforms. For everyone here on Zoom, just press the Q&A button at the bottom of your screen to submit your questions. Don't forget to include your name and age if you'd like a shout out. If you'd like to see captions, you can click on the closed captions button at the bottom of your screen and select show captions. I would now like to invite our educators to come on screen, introduce themselves, and we'll get started.
Hi friends, my name is Katie. My pronouns are she and her, and today I'm going to be your guide as we explore space, but all I will be doing is the talking.
Hi everybody, my name is Talia. I use she, her pronouns, and I'm going to be doing the flying today, flying you through the solar system and around space.
Awesome. So I thought it would be fun today to talk about some of my favorite spacecraft. I know some of them are Talia's favorite spacecraft as well, and really kind of dive into how we know the things we know about astronomy, because most of what we know is due to telescopes and sending spacecraft out into space. So we're going to look at several of these instruments today, and we will start on the edge of our solar system in a program called Worldwide Telescope. So this is a free open source software. If you're interested in downloading it, you can find it at worldwidetelescope.org/download. I believe it is only available for Windows. So if you have a PC and you want to check it out, please feel free. We'll have the link for you at the end of the program. So right now what we're looking at is our solar system. So right at the crosshair in the center there is the sun. And then we have pretty much all kind of clustered right in that crosshair area. We've got the orbits of Mercury, Venus, Earth, and Mars. And then just outside of that, we've got Jupiter, Saturn, Uranus, and Neptune for all of the planets in the solar system. And then there's that one wonky orbit, that white orbit out there. That is the orbit of Pluto, which is no longer a planet. That was changed back in 2006, I believe. So now we call it a dwarf planet, but we still have the orbit up just because, you know, it's Pluto and it's a cool place. So our solar system, compared to other stars and our entire galaxy, is pretty small. When we are talking about how far away other planets are in our solar system, you know, we can actually send spacecraft to other planets in our solar system, and we can't do that to other solar systems in the galaxy. They're just simply too far away. So we're going to be talking about a few different types of ways that we study the universe, and the first one is spacecraft that we have actually sent to the places that we are studying. So our first stop on today's trip is Jupiter, which is a gas giant. It's the largest planet in our whole solar system. So if you could open it up like a cookie jar, you could fit over 1,300 Earths inside of it. And it is made of gas, mostly hydrogen and helium gas. But I want to talk about how do we know that? And part of it has to do with two specific spacecraft that have studied Jupiter up close, that actually orbited around Jupiter. So we've sent spacecraft to a lot of the outer planets, but a lot of the times they just fly by, so they don't stick around for a long enough period of time to collect a ton of data. So the first spacecraft to ever settle into orbit around Jupiter was the Galileo spacecraft in the late 90s into the early 2000s. And it taught us a lot about the planet itself, including its composition, but also its moons. So I believe we can actually travel to maybe a couple of Jupiter's moons, or at least see the orbit. So these four orbit lines that you're looking at right now are the Galilean moons. So they are the largest moons around Jupiter. and some of the largest moons in the solar system. And Galileo studied some of these moons, including Io and Europa specifically. Io has a whole bunch of volcanoes all over its surface, and Galileo showed us how those volcanoes actually have an effect on Jupiter's atmosphere. And it's also the most volcanically active place in the entire solar system. It also took some observations of the moon Europa, and the data that came back from the spacecraft was in line with what astronomers had previously predicted, which was that Europa has a subsurface liquid water ocean. So it's very cold out here. We're really far away from the sun. So any liquid water that's just kind of exposed would definitely be ice. And we do find a lot of water ice out in this part of the solar system. And we never thought that there would be a place warm enough out here for there to be liquid water. But it turns out that on the interior of a lot of moons, it is warm enough due to something called tidal heating, basically gravitational interactions with, in this case, Jupiter, that cause the inside of Europa to be much warmer and allow for a liquid water ocean. And some of the observations from the spacecraft also suggest that that could be the case for the other two Galilean moons as well, Ganymede and Callisto. So we learned a whole bunch from that spacecraft. And then along came another one called Juno, which is still in orbit around Jupiter. And this spacecraft specifically is in a polar orbit around Jupiter. So it gets a good look at Jupiter's poles, and it's studying a lot of Jupiter's magnetism. So it's looking at what is the core of Jupiter made of that makes it have such a strong magnetic field. The gas giants also have aurora, kind of like we do here on the Earth. So this spacecraft is tasked with learning more about the magnetic field of Jupiter, which will hopefully lead us to learning more about the interior and what exactly is at the core of Jupiter. It also has a ton of beautiful pictures of the storms on Jupiter, including the Great Red Spot. So if you want to see some really awesome pictures of Jupiter's massive storm, then I highly suggest going to NASA's website and looking up pictures from the Juno spacecraft. So Talia's just brought the Great Red Spot into view. It's incredibly massive. It's about the size of the Earth, maybe a little bit bigger. It used to be a lot bigger than the Earth, so it is changing over time. And that's something else that we know from Juno because it's measuring a lot of the wind patterns on Jupiter. So I just gave you lots of information about Jupiter and the spacecraft in orbit. So I'll pause and see if there are any questions before we head to our next stop.
We certainly do have a lot of questions. I can't say that they're all about Jupiter, but we'll throw some at you.
Sure.
So just kind of starting at the very beginning, Leah asks, when did we discover the solar system?
That's a really good question. And the answer to that is we don't really know. So a lot of the planets in our solar system, and of course the sun, you can see with your own eyes. I mean, you shouldn't ever look directly at the sun, right? That would be dangerous, but you still know that it's there. You can see the light from it. So as far as we know, humans have known about the sun and some of the planets for a very long time. And it's really hard to kind of pinpoint who was the first person and when to recognize, certain objects up in the sky, because you can see Mercury, Venus, Mars, Jupiter, and Saturn all with the naked eye at nighttime. So it's really hard to tell who, saw them and discovered that they were planets in the first place. The first planet to be discovered through a telescope, so actually using a telescope, was Uranus, and it was in the early 1800s. I think it was 1801. By a guy named William Herschel. So he was the first one to actually discover a planet, because it's really hard to pinpoint when the other ones would have been discovered. It's a good question.
Thank you. I think maybe two more and then we'll continue on.
Sure.
So the next one from Zara, age 6, once again, asking about things starting at the beginning. How are stars made?
That's a really good question. And it's one of my favorite questions, actually, because I love talking about how stars form and live and eventually die. So, stars have whole life cycles. They're not alive like what we think of, as you and I being alive, but they do form and then have a source of fuel throughout, billions of years. And then eventually they run out of fuel and they die, quote unquote. So, which means that they either explode outward in a huge supernova, or they become just a really compact object. So, basically, stars form in these giant clouds of gas and dust called nebulas. And when I say giant, I mean really giant, like many, many light years across. So in these giant clouds, sometimes that material clumps together. So you can kind of think of like a dust bunny, right? A dust bunny might start really small and then over time it kind of attracts and picks up more dust around it and it gets bigger and bigger and bigger, or maybe like a snowball. That's kind of how it happens in a giant cloud or a nebula of gas and dust. Is this material clumps together, gets so big that eventually it collapses in on itself because of its own gravity. And then at that point, there's lots of high pressures and temperatures in the core that start a process called nuclear fusion. And that is what drives and fuels a star throughout its whole life. So, to put it, I guess, more quickly than that, a bunch of gas and dust that squishes together and collapses down. And that's how stars form, including our own sun.
Thank you so much. And to bring our attention back to what we have on the screen here, Felix is asking, why can we only see what looks like half of Jupiter?
Yeah, that's a good question. So, right now we're looking at Jupiter from space, and the sun is at the center of the solar system. So, the side of Jupiter that's facing the sun is lit up, and the other side is the nighttime side of Jupiter, or the side that's facing away from the sun. So, just like the Earth, how we have daytime and nighttime because the Earth spins around, we're just looking at Jupiter's daytime side and Jupiter's nighttime side. On Jupiter, though, a day is a lot faster than a day on Earth because Jupiter spins more quickly. So a day on Jupiter only lasts about 9 or 10 hours. So you only get, like, if you were on the, in the atmosphere and the surface of Jupiter, you'd only get like 4.5 hours of daytime and 4.5 hours of nighttime. All right. So for our next stop today, let's head over to the next planet in the solar system, or the next planet out. We'll go to Saturn. And then we will talk about things that are much farther away than the planets in our solar system. So Saturn is about 1 billion miles away from the sun. And just for reference, the Earth is about 93 million miles away from the sun. Jupiter is about 500,000,000 miles, and then Saturn is closer to 1 billion miles. So we've almost doubled our distance just traveling out here to Saturn. So when we send spacecraft out to Saturn, it's going to take a lot longer. So the first spacecraft to enter orbit around Saturn was Cassini, and this spacecraft lasted a very long time, much longer than astronomers initially anticipated. And so we have basically everything we know about Saturn now is because of this spacecraft. It is truly an amazing, informative instrument. So Cassini was launched back in the late 1990s and arrived in 2004, and it lasted until 2017, so just a few years ago. And when it was heading to Saturn, it brought along a friend, not a human friend, but a rover. So this, or a lander. So that was called Huygens. So the whole thing together was called the Cassini Huygens probe. And Huygens was tasked with landing on the surface of Saturn's largest moon, Titan. And that was the first time that we astronomers had ever sent a spacecraft to land on the surface of a moon other than ours, and also the first time we landed anything in the outer solar system. So it was really exciting. And when it landed on the surface, it didn't last a very long time. It lasted just over 2 hours, I believe. But it did take a lot of great data, and it sent us some pictures about what it looks like on the surface of Titan, Saturn's largest moon. And it turns out that it has an atmosphere, which is kind of weird for another moon. We don't see a ton of moons with atmospheres, but it does have one, and it's actually got lakes and rivers all over its surface, but they are not liquid water. They're made of liquid methane because, again, it's very cold out here. So any kind of liquid on the surface of a moon or a planet would be frozen. So this is liquid methane. So it's got a whole methane cycle on the surface of Titan, which
We
is super
actually
cool.
have, if you don't mind if I interrupt, Katie, we
Yeah.
actually have a question about why is space so cold from Aaron, age 8?
Yeah, that is a really good question. So space is cold because there's not a lot to warm it up. Like the closer you get to a star, there's a lot of heat coming out of a star, but you kind of need to be able to retain that heat. So the reason that the universe is cold is just because there's nothing to heat it up unless you're near a star or, an object that is warmer. So like Earth, for example, the reason we're warm on the surface, it helps that we're closer to the sun than Saturn is, for example, but we also have an atmosphere that traps in and holds the heat for us. So even though, we're not as close as Mercury, for example, we can still stay warm because of our atmosphere. So it's really just because unless you're really close to a star, then there's nothing to heat you up. That's a good question. All right. So that's a little bit about Titan. The planet Saturn itself, we learned a lot about the ring system and the composition of Saturn, including the weird hexagonal formation that's at the pole of Saturn. So this is kind of like a storm, and each side of this hexagon is part of a jet stream. So there's heavy winds at Saturn's North Pole, I believe. Is that right, Talia? Is this the North or South?
We are looking at the North Pole.
Okay, cool. Thank you. So we've got this weird storm at the North Pole, and then at the South Pole, Cassini also discovered a lot of hurricanes. So there are just so many discoveries that came from Cassini. So I could go on and on, but those are just some of the main most important discoveries. All right, so we have about 10 minutes left. So let's leave Saturn behind and let's talk about two other spacecraft that are some of my favorites. So for this one, we are going to switch to the night sky view. So instead of kind of traveling through the solar system like we just were, we're going to just pretend like we're on the ground. I guess we don't have to pretend, we're all on the Earth right now, but now that we're looking up at the sky. So are there any more questions, maybe anything around Saturn or anything else so far, Emily?
Yeah, so we did have one question about Saturn, and they mentioned something about Saturn having a bigger ring. Could you talk a little bit about Saturn's rings?
Yeah, that's a good point. I just basically glossed over the rings. So the rings of Saturn are made of ice, and they're tiny pieces, or not tiny, but chunks of ice, I should say. So they're not solid all the way around. So you couldn't like walk all the way around Saturn's rings. They are chunks of water ice. So some of them are as small as your hand. Some of them are as big as a cruise ship, but they're all kind of orbiting in that plane around Saturn. So It looks flat because the rings are actually quite thin. Um, in some places, they actually get as thin as 30 feet. And then you might have noticed that there are some gaps in the rings. So the gaps are actually caused by moons that are in orbit around Saturn. So basically, the moons have a gravitational effect on all of the chunks of ice in the ring system, and so does Saturn. So these gravitational interactions end up creating some of those gaps. So there's a really big gap, and that's probably what you were looking at when you were seeing like a more of an outer ring. That giant gap is caused by a moon that orbits fairly close to Saturn, and it just has to do with the gravitational interactions.
All right, maybe one more question, then we can move on. We have a really interesting question, both from June, age 6, and Tiffany, asking, how do planets get their color?
Yeah, another awesome question. So it really depends on what the planet is made of. So when we think about Mars, for example, we call Mars the red planet. Um, and that's because the surface of Mars does look red. And that has to do with what's in the soil on Mars. So when we look at the composition of Mars, which we know from many spacecraft that we have sent to the surface of Mars, we know that there's a lot of iron in the soil. And so iron, if it's exposed to oxygen, it oxidizes or it rusts. So if you've ever left a bicycle outside for too long, or maybe it rained, or you've left an earring in the shower or something like that, it oxidizes and gets rusty. So that's essentially what's happening on the surface of Mars. Mars has a very thin atmosphere that does have a teeny tiny bit of oxygen. So it's able to rust. So Mars is essentially covered in rust. Jupiter and Saturn are also colorful because of what makes up their atmosphere. There's a lot of ammonia in Saturn's atmosphere, which gives it a yellowish color. Uranus and Neptune are blue because there's a lot of methane in their atmosphere. So it all has to do with the composition. Great questions. All right, so let's move on, and I want to talk about the Hubble Space Telescope because this one is pretty popular. A lot of people have heard of it before and have seen beautiful pictures from it, and it is one of our most powerful telescopes. And the Hubble Space Telescope has looked at all different types of objects in the universe, from planets in our own solar system to the farthest reaches of our visible universe. And that's kind of where I want to focus. So the Hubble Space Telescope is in orbit around the Earth, and so it's up above the atmosphere, so we don't have to worry about viewing conditions like we do if we use a backyard telescope. It's in orbit around the Earth, low Earth orbit, so it's not too far away. And it has looked, again, at just so much out there. So the first thing that I want to show you that I think Hubble is maybe most well known for is an image called the Hubble Ultra Deep Field. And so Talia can actually zoom in on that for us. And this was done, I believe, in the early 2000s. And basically, Hubble took a picture, many pictures, of a really, really small point in the sky. And it took these pictures with long exposures and many, many exposures. I believe that Hubble had to make 400 orbits to complete this image. This is a very, very small portion of the sky. And when all the data was collected and put together into this image, we see about 10,000 galaxies. So other galaxies, not inside of our own, not inside of the Milky Way, but outside of our galaxy. There are about 10,000 just in this picture alone, which takes up just a little pinprick of the sky. And some of these galaxies are the oldest ones that we know about, and they teach us a lot about the early universe. So some of the really small, redder looking galaxies that don't have a well-defined structure, those are galaxies that are 13 billion light years away. And when we're looking up at the sky, we're looking at objects as they were in the past because it takes time for light to travel through space. So the light that we're seeing from a star that's 8 light years away, for example, we're actually seeing that star as it was 8 years ago. So with these galaxies, some of them being 13 billion light years away, we're seeing the light from 13 billion years ago. So we can actually see and observe what the universe was like, in the first billion years or so. So there's a lot of galaxies like that in this image. There are also a lot of galaxies that are much closer than 13 billion light years away. And like this one you're looking at right there, it's got a pretty well-defined spiral structure. So that means that there's probably been, that one is a lot closer because there's been more time for that galaxy to kind of settle into that spiral structure. And same thing for a lot of these other galaxies that you're viewing. But this is kind of our first look really deep into the visible universe. And each one of these galaxies has anywhere from millions to trillions of stars in each of these galaxies. And then there are probably around the same number of planets out there as there are stars. That's what astronomers estimate, at least. So, just in this picture alone, the amount of stars that we're looking at is trillions and trillions and trillions of stars. And this is just a tiny part of the sky. Imagine if we took an entire survey of the entire sky, how many galaxies there would be. And astronomers have estimated that there are probably around 2 trillion galaxies in the entire universe. Or excuse me, in our observable universe. So just the universe that we can see. Another thing that came out of this picture and just Hubble's studies, I guess you could say, Hubble's observations, is that we know that the universe is expanding now because of Hubble's observations. A lot of those galaxies that are redder appear red because they are moving away from us and are moving away from other galaxies. So we have a lot of this information about the expansion of the universe and how fast is it expanding due to observations from Hubble. So that's why Hubble is one of my favorite spacecraft, in addition to the other two. I had some more, but we are out of time, so I'll save them for another show. I don't know if we have time for maybe one more question, or maybe that's it. I don't know.
Let's see. Yeah, maybe we can do one more question, but okay, we'll take this question from Nico. What is the largest known galaxy?
That's a really good question, and I don't know what it is, but I can tell you the largest galaxy close to us, and that would be the Andromeda galaxy. It's our nearest major neighboring galaxy. It's the biggest one in the local group, so our kind of general part of the universe and our neighborhood of galaxies. And Andromeda has about 1 trillion stars in it, compared to the Milky Way, which has about 300 billion.
All right, thank you so much. I know we didn't get to all of your questions, so I'm so sorry. There's just so much to learn about space. My mind is quite blown at the moment. So I'd like to invite my educators to wave and say goodbye.
Bye, everyone.
Thank you so much. And thanks all of you for tuning in and just being such great, amazing scientists and asking awesome questions. So thank you so much for being here. To check out more programs, you can visit the website mos.org/MOS at home, or follow us on social media. And if you've enjoyed today's presentation, please visit the website on screen to support MOS at home. Thank you, everyone. Enjoy the rest of your day, and we'll see you next time.